All right, everybody. Well, thank you guys for logging in and carving out some time to learn a little bit here. I am joined by Eric Harkins. Eric is the owner operator of Back 40 Aerial Solutions. He was one of our guest speakers at our last quarterly meeting, so you might have heard him there or just throughout your interactions in the world. But Back 40 is a full-service aerial solutions provider, and they specialize in a lot of things, including inspections, construction progress reporting, high-resolution imagery, 3D modeling, and of course, the subject of today's webinar, which is LiDAR. And if I'm remembering this right, I think the company was founded in 2016, something along the lines of 3,500 missions. Hopefully, I'm not getting those facts wrong, but all that to say that Eric is a seasoned drone operator, pilot, data collection, GIS guru. So we're fortunate to have him on. So with that, Eric, I'll go ahead and turn over the rest of the webinar to you, and I look forward to hearing what you have to say.
All right, great. Thank you, Joe. Good afternoon, everybody. I'm struggling with a little bit of a cold today, so if you see me just kind of pause, I appreciate some grace. I'm just trying to gather my thoughts, in the middle of stuffiness. So, as Joe said, we're a private company. We're based out of Blythewood, South Carolina. We do travel all over the Southeast and East Coast for work. We started off with Phantom 3 Advanced long time ago now, it feels like, and have merged some of my experiences, my professional experiences, into data acquisition specialties. So I'm going to kick it off here. As you know my name, there's my number down there. If you need to get a hold of me for some reason, it'll be at the end as well. So we are one of the state's longest continuing operating service businesses. We were doing the 333 before 107, and now they don't even require a 10729 as long as you go through the online renewal process. We've grown. I'm proud to say we've grown the business tremendously over the last 3 years. As many of you know, COVID, forced people to reevaluate the usefulness of drones because we couldn't get personnel on site, right? So we pick up these other things here as 2D, 3D aerial, mobile, SLAM. We really specialize in land development, be it industrial parks or residential. We're starting to get more into state projects. We just did one with Francis Marion to assess the campus roads and parking lots. So we're obviously here trying to meet more folks where we can lend our expertise and maybe even equipment if you have some expertise of your own. So I am from South Carolina. Before that, I have a forestry degree from Clemson. I've worked in GIS, I've worked in IT, I've worked in policy. So those seemingly unconnected experiences at the time have really created the foundation for my business and the expertise that we were able to lean into. If you can read here some of the things I've done along the way and a few of the firsts. So the other thing that I was actually really pleased with was working with Kitty Hawk when it was one of the first to put out the Before You Fly app. I was a customer success manager there, and we worked with people all over the country, and it kind of changed my perspective on service providers because there's plenty of knowledgeable folks out there, and they just might not know that one thing. And together we can collaborate and figure that one thing out. So that was a really valuable experience in my career. So I'm just going to jump right into it. I think, Joe, if you could put up one of the poll questions or both of them, just to get a feel for
Sure.
A little experience in the room on the topic. We can wait for just a minute.
You should see a poll in front of your screen now. Do you see that?
I do. All right. Okay. A couple more folks. There we go.
Can you see the results?
I can.
Okay, good.
I'm sure if everybody else can, but I can read the poll results here. We have about 40% of folks saying yes, they're familiar. 22% say no, but they want to. 26% say no, not relevant at all, and then 11% what is a point cloud. So that I appreciate y'all answering that. That it certainly helps me understand and kind of gauge the room to where I need to spend time. All right, Joe, you got another one here, just so you can see where the folks fall on
Okay, there should be another one up on the screen.
use cases. Got about 7 more folks. So I just want to clarify, in this circumstance, I do not sell equipment. That's been a personal choice that allows us to stay agnostic. There are a lot of folks that I know all these vendors, and the reality is I know the people that sell those vendors their stuff. And so if there's specific use cases or
I just ended the poll and I'm sharing the results with everyone. Looks like 68% want to learn more about uses for LiDAR.
Okay. All right. Flying it in-house. There we go. Yeah, so we got a good spread here. I think the thing to mention in this is that the prices on this equipment has come down. Generally speaking, you're going to be flying with either a Matrice 600 or a DJI M300 or some other Blue UAS Group American manufactured unit that will be able to carry the payloads. I've done testing for about 5 years now, I guess, and come along as equipment is evolving and software is evolving. And so it is now getting to a rather affordable point to purchase if you're going to use it regularly. The other thing that a lot of folks maybe don't consider is the annual renewals on the software licenses. Us as a company, I have about $25,000 in software licenses annually, but that's by choice. We do a lot of different things. We have TopoDot, we have Inertial Explorer, we use Rock Cloud. So there's a lot of things that I've chosen to streamline. And so it's worth it for us to pick up those extra licenses to be very specific for the job type. And then of course the equipment itself, which you guys know, but okay. So I'm sure you've had time to read this screen over here about the how LiDAR works, light detection and ranging. Traditionally, and we're going to get into some diagrams here in a minute. Traditionally, this has been operated from either a plane, the ground on a vehicle, or a terrestrial tripod scanner. What we found is, there are different types of lasers, obviously, and each one of them has its strengths and its weaknesses, depending on what you're trying to do. So here's a couple of examples of how the science of this works. You're sending out light pulses. If we have any law enforcement officers in here, everybody talks about radar guns. They've been using LiDAR guns for a while to detect speed, and that's the same thing that we're doing here. We're detecting how long it takes for that light to return back to the optical sensor in the LiDAR housing, and then because we know the speed of light is a constant, we know the distance that it traveled. There are, as I mentioned earlier, different types of LiDAR. We generally have a single return, a double return, or a 5 return. Those 5 returns are the higher end of the Regal systems that are still over $150,000 for just the sensor. But we do utilize some lower end, well, they used to call them lower end, but we've proven that the data is within 90 to 95% confidence level of a much more expensive sensor to get a dual or a triple return point cloud. So the other part that occurs is how many lasers are actually in the scanner itself. the DJI LiveVox, which some of you may know is on the L1. That sensor is a single laser, but they use a prism to reflect it around to create a very robust system. There's others that have 8, 16, 32, 128. So those are comparable to, well, let me rephrase that. The more lasers you have, the more data you're going to generate in the post-processing, which can be a good or a bad thing, depending again on your use case. So for forestry, as an example, you would want more lasers, you would want more returns so that you can hit those trees at different places along the flight path. Whereas if maybe you're just looking for a basic, hey, I want to 3D model this building, we just want to do something simple to create a twin that we can reference, a single or a dual return LiDAR will do that. We'll do that within reason. So the other part that I wanted to bring up, because some people did say they're familiar with point clouds, and I assume most folks are familiar with photogrammetry. And so what we see here on the left is the two different processes for how that data is collected. In photogrammetry, you're using known positions that you identify in the imagery and that have been collected with a GPS or a total station on the ground. And then it kind of tells the camera, hey, you weren't really where you thought you were, you're actually over here. And so the photogrammetry tries to rebuild upwards from the ground, from the pictures. Whereas LiDAR is direct, and we use a base station, which is a permanent position during the flight, and then it corrects. It says, hey, I know this GPS was here, and I know that the LiDAR was here. They're close enough that I can take any error that was seen from the GPS satellites, and we can correct them the same way to get a very accurate, very precise point cloud. A lot of people say, oh yeah, you can do this without ground control points. Personally, in my experience, I don't like that. I don't trust that because you need to validate your results, right? And the way to do that is to have some checks on the ground. Where the other thing in photogrammetry, if you're using targets for ground control points, it warps the model to those points. So if you don't have a lot of them or they're not evenly distributed, the model can warp to try to best fit what you do have. Whereas with LiDAR, it's just, this is where the drone was, and this is what the laser saw. So you do get some alignment, what they call strip alignment, but that is much less common now. What we're seeing is military grade inertial measurement units that would be in missiles that have been sitting on the shelves because they couldn't sell them to the government for the last 20 years. They're finding new markets for those, and those are coming into these LiDAR systems. So they're actually incredibly accurate versus where we were just 2 years ago, and they're more forgiving as well. The other point here is your point density on the ground.
Hey, Eric, sorry to interrupt. Yeah, this is David. So I want to make sure I'm understanding this right, that the positioning systems for missiles have literally been taken out of missiles and now are being incorporated into commercially available LiDAR systems. Is that a fair summary of what you just said?
Physically taken out of the system.
Sure.
Like unsold stock from the company. Okay. To whoever was assembling the missile, right? Because you got a supply chain. Sure.
So they have the positioning systems on the shelves, and now they are reusing them for LiDAR purposes.
Correct.
Okay.
Correct. For navigation, basically.
For navigation, exactly.
And they're going into vehicles too. You want to talk about autonomous vehicles and like Caterpillar equipment that drives itself, right?
Right.
These high accuracy inertial measurements and gyroscopes are, again, still kind of old tech.
Yeah. So my follow-up question, and I understand I'm asking a very niche question, so I completely get if you have no idea what I'm talking about, but do you know if these systems are ITAR controlled?
I can find out.
Okay.
I would assume there are certain ones that are not, because
I would think so too, but the way you described it, it's a very big technological leap in a very short period of time that at least perked my ITAR ears, for lack of a better word.
and Trimble are the two main, Planix are the two main manufacturers of those systems. Novotel is a Canadian company, so we
Sure.
have the remnants of NAFTA where we can come and go. I do see people say these things are American equipment, and they're not. You got a Japanese camera, you've got a Chinese
Right.
little body, you've got a IMU. So from the legalities of that, you got to kind of check. And I know how these things are manufactured, so you feel free to ask me. I know who's doing what. But yeah, in terms of the accuracy, it's incredible.
Yeah. Yeah.
Democratize the approach, because you had to have something that was big enough to either fit on a plane or a big enough drone to fly. And your flight time might have been 15 minutes on a Matrix 600 with one of those units. Whereas one of the point clouds I'm going to show you, I went out and captured last night, processed last night, and it is ready to view with extremely high point cloud density, which is kind of what this other graphic is talking about, right? Usually from a plane, your distance creates a spread, just like in photogrammetry. The higher you are, the lower the resolution of the resulting imagery. And it's the same way here. The farther you are away in terms of altitude, the less dense your point cloud's going to be. Let's see what's next here. These are some of the ground control targets that we use. The one on the left is vinyl, it's foldable, it's 3x3. The one in the middle is something we have manufactured. It's actually rubber sandwiched with aluminum. So it makes them very convenient to be able to just place out in a permanent fashion. What we found was the other two don't last 6 months, sometimes less, depending on the temperature swing and the humidity and just where they are. But we've had really good results with the one in the middle lasting for about 18 months on site. And so that cuts down on your cost of having to have someone come out and reset control, survey it. Maybe you're doing the GPS work yourself, but it's still a pain in the butt to go out and reset that over time. So that's just kind of a little insider secret as to how we can increase efficiency on these and photogrammetry jobs, because they'll, like I said, they'll last a long time. So we're talking about ground control a few minutes ago and how that is applied differently in photogrammetry versus LiDAR. Here's just a visualization of how the triangulation occurs in photogrammetry, and that you need sufficient overlap between pictures, whereas with LiDAR, you can get away with 25 to 30% overlap between flight lines, which makes you extremely efficient. The ability to cover large acreages is there, and because of the accuracy of the GPS and the base station, sorry guys, I'm drawing a blank here, the trajectory post-processing, that ensures that we really just use those ground control points in LiDAR to adjust the point cloud to a statistical deviation to make sure that it's in the right place. But once it comes in and fits, we're usually under 1/10 of a foot in the vertical. Sometimes, Joe and I were talking about this before. These are some things to look out for when you're doing these missions. A lot of people don't consider how far you are away from the base station that you've set up for either photogrammetry with RTK or with LiDAR with PPK, which is post-processing kinematic. You got to pay attention to solar storms. We have a lot of electromagnetic interference that comes through the atmosphere and distorts the signals between the satellites in orbit and the receiver. That can cause issues with your data. That's usually the first place I look when I have things that are misaligned. The other thing could be your speed. Whereas with photogrammetry, you got to worry kind of like about your shutter speed and motion blur. With LiDAR, it's more or less about the tilt. And if the tilt while you're moving at speed is acceptable to the angle that you're trying to scan whatever the object may be. So that's something to keep in mind. But we've also used that to our advantage. If we're trying to side scan something, maybe trees, we want to see more down into the canopy. We don't want to be direct over the top. We want that angle. So understanding the parameters of what the equipment can do allows us to be more flexible with how we use them for specific applications. And that's kind of what I bring to the table is those years of field experience with these types of uses. So we talked about operational efficiency. This is, as you can read, a 430-acre solar farm. We flew that in 4 flights with the Matrice 300. And we had very tight vertical accuracy in that. We were able to break the project into 2. So basically a set of 2 flights with 1 battery swap, and then start another mission with 1 battery swap, and then merge those files together. Whereas in photogrammetry, that's very difficult. You can try to line up your overlapping point clouds. Depends on how much skill you got. Sometimes there's software that'll, like we talked about earlier, it'll kind of morph the model, but you have to mission plan that a little differently with photogrammetry. Whereas here, as long as you kind of plan some control points in the middle, in your overlap, you can validate that result between the 2 of them and merge them together with very high accuracy. So it makes for some ambitious projects that can suddenly start coming together in really fast fashion. Let's see here. So dense data of large or small areas. The other big thing that you get with LiDAR that you don't with photogrammetry is the ability to penetrate through vegetation. That dual or triple return allows the laser. There's a good metaphor here. If you're walking through the woods on a sunny afternoon and you see dappled light coming through and hitting the ground, it's very much the same thing with the LiDAR. If there's a pulse of light that comes through and hits the ground, then you'll have a return there. So that's a thing that has really made a differentiator for our operations, because we've worked with a lot of civil engineers, land planners, surveyors, and so the time savings in going out and collecting this data and validating it, and even drafting, in Civil 3D, getting 3D items out of it is a lot faster. 2D as well. You can pull planimetrics out of it as well, but that kind of depends on what your goal is. Depends on the tool that you want to use for the application. These days, most LiDAR payloads do have a co-aligned camera. So if you want to bump up the overlap, you can still get something 50-50 or even higher that you can create a usable ortho image out of. But we found usually within about 40% overlap, there's enough image to colorize the point cloud between different flight lines. So that becomes useful as well, because just like photogrammetry, you have a colorized point cloud off the same flight. So I do want to bring your attention to this right here. Going back to the farther you are away from the object, the wider that beam is, right? And so really thin, fine features, even when you're close within 50 feet, might not have a great definition. And so especially with kind of like the forestry applications or building modeling, we switched to a handheld SLAM sensor that can fill in the gaps at a closer distance that will, fill in that lack of density. So you see, let's see, exterior. I'm sure if folks are reading this, you'll have a copy of this. There's a lot of things you can do. There's a lot of people out there that are learning about, the ability to take traditional in the field data collection and bring it to the office, just like we are today, right? And put it up on your computer. And so that's usually what I discuss with our surveying customers. Hey, it may not necessarily be faster, because we're transitioning the field labor to the office labor, but it allows your field personnel to go do something else, right? They may only be on site for one day to fly the drone, or a couple hours or less to fly the drone. And then someone in the office who's a specialized personnel, or we do that as well, helping individuals who want to fly but don't want to process. So that's just kind of the variety of options that you can apply the technology with. Again, these are all things that we've done. This is the Matrice 300 with the Rock Robotics R360. That is the same unit that Phoenix LiDAR sells. It's the same unit that some folks over in China sell. It is literally the only difference is the cost of the software license on the back end and how much of a nicer case they give you up front. Personally, I don't think it's worth the $20,000 difference some of the vendors are charging to get those two items. Then the other thing we have here in the middle is we've done terrestrial scanning with DNR to preserve historical structures around the state. Third picture is utilizing that same piece of equipment, mounting it on top of the truck and driving it around to get a different scan angle to merge with an aerial data set. So it gave us the opportunity to kind of, just a different field of view. I will still say that the aerial LiDAR of that particular project, which was Francis Marion's campus, I thought it came out better than the mobile. There were some areas of pavement sag or things where having the scanner closer to the pavement, showed that level of detail. But in the overall model, the ability to see on top of roofs, the tops of tree canopies, on top of other structures to create a more complete model, I held more value for the customer in the end. The last item you see here is our SLAM sensor. If you're familiar with the company HoverMap, they pioneered a technique for creating a rotating sensor head. So that scanner is 360 degrees, and then it rotates around the opposing axis as well. So that allows us to get all the angles, 1080 view minus what you see with the handle itself. And that's been useful under things like bridges, merging exterior scans with interior. Maybe you're at your office building and somebody needs a new floor plan, but they also need to know the exterior dimensions of the building. You can merge those two together with an aerial and get a pretty high accuracy point cloud. So those are just kind of the four main use cases. And so that last one uses a technology called SLAM. I'm going to bounce forward to talk about SLAM, and then we'll back up and look at that other example. SLAM is a different way of processing the trajectory to tell the laser where it was and correspondingly where the points are, right? And so what SLAM uses is kind of its own computer vision to say, I shot a point over here, I moved, and I recognize that same structure, that same object, and now I'm here. Therefore, I must have moved X number of feet, right? In X heading, XY heading. But it does that, hundreds of thousands of points per second as you're moving. So it creates a very dense point cloud, which you see here in this picture. It's a pergola and some trees. You even see the person standing still over there at the bottom left. And so that has really been a popular technology for creating virtual twins, digital twins. Maybe there's a particular site that you don't get to go to very often, or that is a hazardous site. And so you want to make sure that the personnel are very, very familiar with it before they get on site. You can scan it with something like this, and then put it either in goggles or in a viewer on your desktop so that they can become familiar with that without ever having to go there. You also see that in a lot of video games these days. People want to make custom in manufacturing, custom floor plans, things like that, so they can create virtual twins of whatever the objects may be. So I'm gonna back up here And we're talking about the vegetation penetration. Over here on the left, you have your Google satellite image. And the right, you have a LiDAR that's been thinned down to the ground surface, so you don't see all the trees. You do see some of the little speckles here. Those are pretty much the bases of those. It's a swampy area, right? So it's kind of the base of the tree where it picked it up close to the ground. What I really wanted to showcase here, though, is that under very dense vegetation here and here, and even you can slightly see it coming down this line, you can get drainage. And so LiDAR is, some of you are already using it in GIS, you already know this, but some other folks may not, that stormwater, you can create models out of this that you can put in stormwater estimation software. You can redo FEMA flood maps based off of maybe how things are changed due to erosion in an area. But I thought it was very intriguing that it showcased this kind of pond and a drainage there. And if you go into this next section, what we did is we put it into a grid, and you can see this in 3D, right? And then down here on the bottom, you can actually measure the depth of that canal. You can get a profile of what's happening there. Again, the ability to estimate volume of water that may move through that in a storm event, what volume of dirt might be required to repair the dam, things of that nature. It does a really, really fine job with stream beds, especially small, fine elevation changes in the terrain. So let's see. We'll just kind of go back into this. Here's another watershed that you can see. We've worked with folks on industrial sites to keep track of their erosion control, both with ortho imagery and with LiDAR. We've used it for, as I said previously, we scanned some historical sites. Hopefully we'll be working with FEMA here before too long on the Columbia Diversion Canal. We need to document some items in the canal before they remove that. The other ability to cover large areas. Usually, when you're doing a floodplain map, your vertical accuracy is like, plus or minus 1 foot, it'll be okay, right? But this doesn't do plus or minus 1 foot, right? You can't really create data that bad. And so what it does is it creates a new standard for how you're going to model those types of areas. We can also get into biomass research, through the ability to take those 3D point clouds of trees or other objects and quantify them by removing the ground or other objects to give a more accurate picture of, maybe it's just canopy, maybe it's various things that happen in forestry and other ecological research. But moving along, you can, if you're a municipality, right, you can run maybe your own power like Newberry County does, or the city of Newberry. If you are DNR and you own hundreds of thousands of acres of timberland around the state, and you're wanting to maybe get a better understanding of how the growth rates on a particular stand, these are all very common applications that can be used. And the ability to deploy, as we all know, as drone users, is so much easier than having to go down to the airport, get your clearance, and all the other things that come along with that, insurance and liability, and again, the cost to go out and map these things. I will say that unless you're getting a Regal sensor, you're more than likely not going to be able to mount one of these other items on a helicopter. You're just not going to be able to get low enough to the ground. You can if you're a good pilot, but why, right? Just leverage the drone technology. So again, you can see road assessments, urban tree inventory, vegetation analysis, stockpiles. If you're working, you've got a contractor that's putting in a new stretch of road or something, and they're billing you for work they said they've done, and you need to validate because it doesn't look like it. That's a simple way to do that. Our bread and butter is working with civils and surveyors to extract features. I think GIS is a great fit for this too, because a lot of times you just need a rough estimate of what's there, so you have an asset inventory. And what you see here is the parking lot in the building. What we have here is the islands in the parking lots at Francis Marion University. We were able to extract the vegetation off of the islands, create topographic information, and then use Civil 3D to draw the lines for the top of the curve and the bottom of the curve. And so that's something the surveyor didn't have to go out and spend weeks doing. We were able to collect that data in one afternoon, and in about 7 days, draft it all and turn it back around to them for validation and use in their new design. So I think that's really what I've seen is the biggest market driver, is just the speed to market of that type of engineering information that you can extract out of this. We've done some landfill monitoring at the old Bowater site, which is now New Indy. The ability to go into hazardous sites, this comes back to photogrammetry versus LiDAR, right? If you can place your control points outside of a hazardous site, but still included in the flight area, you don't have to go in there to set GCPs and GPS them. You can leverage the accuracy of the IMU with LiDAR to increase safety. Let's see. Oh, this is kind of basically just a thrown together of all three of those, and then BIM. You can utilize this for marketing. We have construction companies that say, hey, we want to put in a bid. We want to show what the existing conditions are. It's a great marketing piece with our bid. We may also have residents who say, hey, we heard there's this big stormwater project, or there's whatever it may be. We don't know what you're doing. We want to see it. Show us. This is a rather simple way to show. It's a good show and tell. Let's see here. I do want to switch over, since we were talking about this with surveying tradition. I want to show a different program that we utilize called LP360. That is where we quality control all of our point clouds. And let's see if I can get it shared here. So what you might see here, this is the resolution of a traditional, this is actually double the resolution of a traditional ground survey. This would be a 25-foot grid. Can't really make out too much, Then we pare that down to a 5-foot grid, and you can see it all. You can see tracks in the mud. You can see this creek over here that wasn't visible previously. You see the train tracks. You can see the stream basin. And then it's a bit of a controversial topic these days. I wasn't sure I was going to talk about it, but traditionally in surveying, you use break lines because there's those big gaps between points. You want to tell it, hey, there's something here that changes the elevation between two other points. And so if what people have been researching is using full resolution LiDAR to create, to eliminate the need for that. So you can see here, just coming between the 5-foot and this full resolution, part of it's not going to render correctly because there's literally too many points. It wants to crash. But again, I'll just kind of flip back and forth between these two so you can see the resolution between a 5-foot and the full resolution. And that's what I think is amazing about this. The ability to really see what's there, to see this type of resolution under trees. Here, I'll turn this, I'll kind of dull this down again, but I'll turn the points on so you can bear with me. Here's all the trees. We'll do a 3D view here, just behind that pond. So you can see all those trees. Now, in this particular survey, we weren't requested to collect tree locations and diameter, so the way we flew it was different. But again, it still shows the ability to get in underneath all of that interference with a double or triple return scanner. Whereas if you just had the first return, it would stop at the trees. Some of it would go through, but the rest of it would stop at hitting the trees. So, that's, again, I just want to showcase the tech, showcase kind of the idea of what's out there, what we use as different softwares to refine this. I think the biggest part that a lot of folks talk about is flying, but they don't really talk about, hey, how do we classify this data? How do we make this usable and validate that it is correct? And so that's where we've spent the last 2.5 years really leaning into our post-processing to improve that quality. I mean, we use 3 different softwares just to take from the field into something usable that we would provide to an engineer. And all of our work with those folks is stamped. I mean, that's kind of the level of accuracy that we have to work in, because otherwise they're going to be liable for it. So it's really driven us to be as best as we can in these processes to get that correct information. I think here I'll move one more screen here, just so we can look at Francis Marion, because I know I've mentioned that earlier. This is another one of those softwares, Point Rock Cloud. We utilize this to do transformations between a global coordinate system and the state coordinate system. I found it to be very useful because otherwise doing it on my desktop eats up, basically just freezes up the whole computer, trying to make those changes. So we leverage the cloud for that. Let's see, we can get in here. It'll take a minute to populate. But you can see the curbs, you can see trash can. Some of it is also being familiar with the site. We also took imagery with this to layer together to validate what we were classifying. The other thing I'm really excited about is the trees. You have full circumferences around these trees that we can measure from the ground up to get that diameter at breast height. You can see into the trees to some degree to get a canopy structure. So there's the important thing to me is that you guys understand the amount of detail that you can collect, because I think that usually gets the wheel turning for most people to be like, oh man, what can I do with that? What value could that have? How could we change our procurement? How could we keep certain field personnel busy on other jobs that are higher priority without having to go do tree measurements? So that's really, again, my intent is to show the capacity of the technology these days. Then put it out for questions and see what everybody's curious about, where I can offer insight. If you need help, if you need some training, anything along those lines, I'm open to have discussions around.
Thanks, Eric. Is it all right if everyone just kind of turns on their mic and ask a question if they have it?
Yeah, I mean, I think if there's a raise your hand function, that way we just don't have folks.
There is, if you want to use the reactions, it's on the bottom tray of Zoom, and just raise your hand. And Eric, there's actually some chats that are coming in. I can read those off. We have a question that come in that says, I have a question on the Francis Marion image. Did you take something's in the way there?
I see you, Bobby. Yes, we waited for winter break, and we coordinated with the campus and campus safety to make sure that basically nobody was there. You can see the occasional car in the parking lot, but that was also because we needed to get the topography on the parking lots, so it would have defeated the purpose if everybody was there anyway. Does that answer your question, Bobby? I don't see anybody typing. Does anybody else have other questions? There we go. Have you considered using arrow points? I have. We invested in GPS equipment because A, you can buy 2 inlet reach receivers for less than half a pack of arrow points. B, arrow points can walk away. People in the images, yeah. Arrow points are also on the ground, right? So you can't put them in maybe some specific locations that you might want to validate a check shot on. So what we did was we actually had the surveyor, we put the targets out, the surveyor came and shot them. But then while we were on site, we took about 100 additional check shots on the curbs, on their targets, on sidewalks. So we were using that equipment to further validate our results. So that's, I think for me, it's just an efficiency thing because you already have it. Ooh, I do know folks doing it via drone boat. Mr. or Mrs. Knight, I'm not sure what's your first name.
Do you want to read the question? Just in case someone is Alex with the pie.
It says, do you know of anyone using drone to collect bathymetric and acoustic Doppler current profiler data? I do know folks doing that with side scan sonar from a drone boat. I have personally considered it, and magnetometer is just kind of a natural extension of the remote sensing services we already provide. There are folks with, if you go into the UGCS, Universal Ground Control Station, Facebook group, there are definitely folks in there doing it. UGCS has partnered with some equipment manufacturers, and they have made some add-ons for DJI and other drones that will allow you to do that. Let's see. Hey, Matt. Hey, man. Appreciate the product at our Moody landfill last month. LiDAR was the right call and allowed Eric with Back40 to collect accurate data without having to send personnel onto the burning landfill surface to install and measure GCPs. Yeah, so I got to work with Matt in Tetra Tech outside of Birmingham. There's a landfill fire, and it was nasty. It was definitely nasty. And so, yeah, the LiDAR is a really good use case for that. And, Matt, next time I'll bring the infrared, and we can, if it's necessary, right, we'll finish capping that sucker off. Let's see, the forest diameter measurements of individual trees. What is the usual point density required? Do you use 5 return LiDAR? Have you estimated diameter from LiDAR point clouds? We have been working with different scanning techniques. I've worked with the obvious sensor has a linear pattern, but it also has a spirograph pattern. I found that the spirograph with a high overlap between flight lines and perpendicular flight lines, so basically a grid, does a decent job of kind of throwing some extra points in there. We've also, which I have on the other screen here, I have the data that I collected last night from this point. Let's see here. Really what I'm focused on is creating SLAM data sets under the canopy and then merging those with aerial to get the required density. I'm going to show you here. There are some trees that do phenomenal. It picks up, let's see, bear with me here, trying to remember where we were. There are some hardwoods down here in this bottom. So in some circumstances, it picks it up, but then you have issues in auto classification where other vegetation might be close to the cylinder of the tree, and so it just screws up the classification. We're currently working with a software called Vision LiDAR to create our own LiDAR computer vision algorithm to determine, to try to improve the classification in situations like this. But what we found so far is that the best clouds come from that handheld that does the additional rotation. And so, a lot of times we'll just clip off the tops of the trees because all we need is DVH and an XY location for that stem. There are other systems out there that are working towards solving that. I would say right now the Regal is kind of the best bet for using that because of the 5 return. It does create enough density, but if you can offset the cost of that, right, by not spending $150,000, but instead spending $25,000 on a handheld scanner and then another $35,000, $40,000 on an airborne scanner, you come in at half the price and you can still have the flexibility of that scanner walking anywhere you want to go. So that's just that's kind of how I sussed that out. That's the logic I took to scanning trees. But yes, to answer your question, you can pull diameter out of these. I'm just trying to get it to a point where it's automated. I think there's another member and I that were talking about this. I think it was Nicolette. And if there's any folks around that that are drone manufacturers, I've got some crazy ideas. Maybe innovation center or something that lean into it a little more. Let's see here. Any other questions around mapping, LiDAR, use cases, effective range?
Eric, just one question as we kind of get close to the end here of the webinar is if our members are looking to, have maybe a little bit more of a detailed conversation. I see another question came through, but just make sure that they know how to get in contact with you and your contact information.
Okay, yeah, I'll switch back over here to the other slide. There we go. We have our traditional, consumer private industry customers. But what I talked to Joe about, the reason I wanted to work with SCiDuck is that those guys, they don't always care about the science and they don't care about being efficient. They just throw money at problems. Whereas for me, I don't mind that, but I'm more or less about trying to find the answers. I like pushing new use cases. Dr. Wang and I went down to Hopcall. We tested some different parameters on trying to meet a biomass, research that she was doing. So, if you got crazy ideas and maybe you don't have the budget to pay what you would consider commercial prices, I'm very open to those types of conversations because it can be mutually beneficial. And I'm really about supporting the state. I'm a native, and so I think that we have a really good opportunity to do some really amazing things with UAVs in South Carolina. So I want to be a part of that wherever I can. Tree Swift. I will look that up, David. I'm going to type that in right now. Tree Swift is using drones. I've also seen folks using, I've worked with a university in Malaysia and in Australia on utilizing those SLAM scanners for tree extraction. So there's definitely a lot of people moving in that direction, and I think with artificial intelligence picking up speed in the public consciousness, we'll be leveraging that to solve all sorts of problems. Thank you, David. So they're using a backpack. I've seen that use case as well. So yeah, folks, if you have questions, you want any follow-up, if you need to contract services, if you just kind of want consulting on the best way to move forward or what's applicable for your use case, you want to do research and development trials. So I do have a couple of different scanners that we can utilize to see what is best for you. Just reach out. No problem. I'm easy to find.
Well, Eric, really appreciate it. For everyone that's on the call, again, I mean, you see Eric's contact information there. If you don't have a pen and paper handy, just go to SCiDAC's website, go to our industry sponsors page, and you'll find his logo. Just click the logo and you'll go right to it. Or of course, you've got an email from us to invite you to this webinar. You can, just certainly reach out to us and we can put you in contact with them. So Eric, really appreciate you coming on, sharing your time and your expertise with us. It's a really amazing stuff. I mean, I was actually just fielding some private chats back and forth that some folks were saying this is kind of where they kind of had envisioned this technology going years ago when they got into the drone side, and it's just really rewarding to kind of see it's finally taking shape and it benefiting state agencies. So again, thank you very much for your time. And again, if you have any questions, please reach out to Eric.
Awesome. Thank you, Joe. Thanks for putting this together, and thank you everybody for attending. Like I said, y'all know where to find me. I'm happy to help. Thank you.